Hello students, I hope you are doing beautiful mathematics. In this video, we will talk about what is combinatorics. It is a very important topic for mathematical Olympiads like American Math Competition, IOQM and other contests similar to it. It is one of my favorite topics in Olympiad mathematics. It is related to the art of counting. So if you want to count a particular set, let's say a set of objects is there, let's call it A, and there are a bunch of things in that set of objects. The main goal is to count the number of elements in that set of objects. I will give you an explicit example. Many of you are familiar with the concept of HCF, right? So two numbers, let's say 3 and 5, their HCF, the highest common factor, is 1. The largest number that divides both of them is 1. In this scenario, we say that 3 is co-prime to 5. Co-prime means the HCF of the two numbers is 1. Similarly, let's say if I have 8 and 15, their HCF is also 1. So 8 is co-prime to 15. Like this. So one can count the number of elements co-prime to a certain number. Let's say if I have the number 10, then what are the numbers which are co-prime to 10? Positive numbers co-prime to 10 and smaller than 10. Obviously 1 will work. The HCF of 1 and 10 is 1. 3 will work. HCF of 3 and 10 is 1. 5 will not work because HCF of 5 and 10 is not 1. 7 will work and 9 will work, right? 1, 3, 7, 9. So if I have a number 10, I can create a set like this. Now, I might be interested to count the number of elements in this particular set. In this case, the number of elements is 4. There are 4 elements in this set. Now the question is, suppose you have a much bigger number, let's say 2024, and you want to do the same thing. You want to write down the numbers which are less than 2024 and co-prime to 2024. Co-prime to 2024. So there will be a bunch of numbers like that. To write down all the numbers, that's a tedious job. But even without explicitly writing them down, can you find the number of elements in this set? So I'm trying to give you examples of the type of problems in combinatorics that you might face and what is the fundamental principle, the fundamental idea. The fundamental idea is this, that there is a set which is defined in some way and you are trying to count the number of elements in that set for whatever reason. For example, this particular set, the number of numbers which are co-prime to a certain number, they secretly form a group. Now, what is a group? It is usually discussed in advanced mathematics, but it is also discussed in some of the advanced levels of Math Olympiad, Combinatorics and number theory in Cheenta. You can check the link in the description for more details related to our programs. So group theory is usually not taught in school level. In some advanced Olympiad programs, you might see it. But many of the problems in geometry, number theory, combinatorics, etc. are actually motivated from groups. One example is, of course, this one, this particular set, which I have not written down, of course. So, mathematicians have tried to understand such sets for quite a long time. This set goes back to Leonhard Euler. Maybe you have heard about Euler. He's one of the greatest mathematicians of all time. There's an example of a set that Euler studied quite deeply, and the formula to count the number of elements in it was discovered by Euler. This is an example of one type of set. Let's look at another example, another set that we would like to count. Let's say there are 20 teams. These 20 teams are playing a knockout tournament. Knockout tournament means no game ends in a draw, and the loser team, every match someone wins and someone loses, and the loser team is out of the tournament. So that's a knockout tournament. 20 teams are playing the knockout tournament. The question is this: how many matches will be played in that tournament? So this is the set that we are trying to count, is the set of matches. Match 1, match 2, like this. For example, you can think of it like this, that in the first round, there will be 10 matches. 2 teams will play 1 match, 20 teams are there, so there will be 10 matches. So maybe then in the first round, there are 10 matches. The 10 loser teams are out of the tournament, so the 10 winners remain. In the round 2, they play 5 matches. Again, the 5 loser teams are out, and the 5 winning teams are staying in the tournament. Maybe the highest scoring team is taking rest in this round. So the remaining 4 teams play 2 matches. 2 are out. So highest scoring team from previous level and the 2 winners from here, they stay in the tournament. So now we have 3 teams remaining. In the round 4, we again have 1 match, right? Maybe again the highest scorer rests and the remaining 2 teams plays a game, and then there is a final, which is 1 match. So total, you can easily see that there are 19 matches. Now this is interesting because the method that we used requires quite a lot of manual calculation. Now here is a clever way of doing the same problem. This method is sometimes known as the bijection principle. The clever way is this, that you notice that the number of matches played is actually equal to the number of losers in the tournament. Think about it. Once a game is lost, once a team loses a match, the team is out of the tournament. So every match has a unique loser. So in the tournament, if there are 20 teams and 1 team is winning, then there are 19 losers in the tournament. There are 19 losers in the tournament, and they correspond to 19 matches. You see how interesting that is, right? We did not manually count this time. We used reasoning, we used logic, we used ingenuity to solve this problem. It's just now a one-line problem. So this is the art of counting. We wanted to count a particular set, and we employed a clever technique to count that set. So if you are interested in Mathematical Olympiad Combinatorics, you will face these sort of problems and techniques. There are quite a few other techniques and problems. For example, there is inclusion-exclusion principle, there is pigeonhole principle, there is generating functions, all sorts of interesting topics in there. Finally, I will end this video with some book suggestions. If you are starting out with this process, I will suggest Math Circles by Foreman. This is a very nice book with a very beautiful set of problems. And the second book, after you have done this one, the second book is Principles and Techniques in Combinatorics. Okay, this is also a very good book. I usually ask students to complete one book from cover to cover. If you are a student at Cheenta, make sure to take the problem solving classes. Make sure to do the homework problems every week, because that consistency is very important. Talk to your friends. That's also very important. You will find stuff a little bit challenging when you are starting out in a Math Olympiad Combinatorics class. But then gradually when you start thinking, many of the ideas will become clearer. Okay? I hope you like this video. I'll see you in the next one. Keep on doing great mathematics. Bye.